So after discussing the knock control or pre-ignition, let us discuss about the fuel injection system. So as I have told you that the fuel injection system is used in the diesel engines because we require to inject the fuel just after completion of the compression stroke. At the moment when the fuel or the diesel will inject it inside the cylinder head, then it will start burning and the expansion followed by the burning. So we have to supply this fuel at the exact time just after the completion of the compression stroke. So for ensuring the proper fuel injection or the fuel ignition, we have to ensure the proper timing of the fuel injection inside the cylinder head. So to control this system, the indirectly controlled variable is the air-fuel ratio. We have to control the air-fuel ratio or the proper mixing of this fuel with the air inside the cylinder head. Then direct control variable are the exhaust oxygen content. So we can measure the oxygen content in the exhaust of the engine exhaust in the engine. Then manipulated variable are the quality of injection fuel. Which sensor we can use for this purpose? We can use zirconia or titanium based electrochemical sensors to sense the oxygen content in the exhaust. Actuator, fuel injector, which we have to control the fuel injector. So here you can observe the common rail diesel fuel injection system and you can observe the different parts. So here you can observe the electronic control unit. This electronic control unit controls the fuel injection or the solenoid valves which are responsible for the on or off position of different fuel injectors. Here you can observe the different parts or the different variable which are associated with the fuel ignition or fuel injection timing. First thing is the crankshaft speed position. Crankshaft speed position we have to measure to ensure the proper burning or proper ignition of the fuel. Then camshaft speed position, we also require to measure the camshaft speed and position. Then accelerator, pedal, brake, clutch, vehicle speed sensor. So that C are the different C variable is associated with the different things like the brake, clutch, and vehicle speed, etc., etc. Then boost temperature sensor, air temperature sensor, coolant temperature sensor, and oil temperature sensor. So we have to ensure the ratio of air or fuel, or we can say we have to ensure the quantity of fuel which we are going to supply inside the cylinder on the basis of the temperature of different components of the engine. Like the air temperature we have to measure. If the air temperature is very less or very high, then we have to control the volume of the fuel supply, or I can say the quantity of the fuel. And according to the coolant temperature also we require to vary the quantity or the mass supplied of the fuel to the engine. Then oil temperature sensor also very important thing, while this ECU will decide the quantity of the fuel to inject inside the cylinder head. Then come to the next thing, let us discuss on the ECU based on the microcomputer. So this ECU is based on the microcomputer. So here you can observe that should have some battery to supply the power, then analog signal will supply from different transducers, then digital signals from the switches and switches, Then this analog to digital converter and manipulator input interfacing microcomputer output circuit output microcomputer is used to decide the parameter or the output circuit parameter which we have to control. So this different algorithms are stored in this microcomputer. Based on their algorithms, that this computer will decide some parameters, and that parameters are responsible for the engine performance. So these parameters are basically we require to supply to the different control very different control unit, or we can say the different parts of the engine which are associated with the engine efficiency. So these signals we have to supply through the output circuit, like to the motor, solenoid bulb, LED and lamps of your vehicle. Then next thing is the engine management sensors. So the engine management sensor, the first thing is the intake manifold or absolute pressure. We have to maintain the intake manifold absolute pressure in order to ensure the proper efficiency of your vehicle. So these such types of sensors which are basically responsible for the engine efficiency or the entire power output of your vehicle are known as the engine management sensor or the engine management systems. So the system which is basically responsible for the efficiency of your engine or the efficiency of your vehicle is known as engine management system, and the sensors associated with this system is known as these engine management sensors. So which type of sensors we will use for this purpose we will see in this topic. First is the intake manifold absolute pressure. We have to measure the intake manifold absolute pressure in such a way that we can supply the proper air fuel ratio inside the cylinder in order to achieve the proper power from the engine. So for the measurement of the pressure, we can use the different pressure sensors. But before that, let me explain you the intake manifold. What is the intake manifold? Intake manifold is basically the part of the engine which supply the air to different cylinders. So here you can see this is the main pipe which contains the high pressurized air. That are different pipes which are connected to the different cylinders head. Like you can observe here, it is the one cylinder head, second, third and fourth cylinder head, and these are different intake valves. So we have to connect these manifold with the intake valve. So it is the intake valve of first cylinder head, intake valve of second cylinder head, intake valve of third cylinder head, intake valve of fourth cylinder head. So we can say this is a four-cylinder engine. And here you can also observe the exhaust valve. This exhaust valve will also be required to connect with the exhaust manifold. So there will be the different manifold system: exhaust manifold, intake manifold, fuel supply manifold also. So we have to ensure the proper pressure of the air inside this exhaust manifold. So for this measurement, we can use the intake manifold absolute pressure measuring device. So here it is the schematic or block diagram of the sensor. Here you can observe it is the hose fitting to the manifold. It is the sensor, so we require to fit this sensor with the hose or the manifold. So we can put this sensor somewhere here in order to measure the pressure. You can mount the sensor in such a way that so this when at the moment the air will come inside this sensor, then it will apply some pressure to this diaphragm. So this diaphragm will when the air will apply some pressure force on this diaphragm, then it will get deflected. With respect to its deflection, some resistance change there will be some so with respect to the deflection there will be some changes in the resistance, because there will be some elements which will change their resistance according to the deflection in this film. Here you can observe. So there will be a connection in the form of Wheatstone bridge. So by measuring that resistance, by measuring the changes in that resistance, we can correlate the change of that resistance with the pressure difference. So here in this chamber, here it is the reference pressure chamber or absolute vacuum or zero pressure we can consider. Then D is the Pyrex glass, and E is the sensing resistors on silicon diaphragm. So silicon sensing resistors are used in these sensors basically. So this will use to sense the or this will use to measure the pressure inside the intake manifold. And here you can also observe the display which we can put on the dashboard of your car, of your vehicle. So in this case, what will be the measured variable? Measured variable will be the intake manifold absolute pressure. Direct, indirect measurement. Indirect measurement of engine load or mass airflow intake. How much mass we require to flow, how much mass of the air we require to flow inside the cylinder. Sensor technology reference, Wheatstone bridge arrangement of thick film resistors bonded onto a thin alumina diaphragm or silicon diaphragm we can use. So the thick sensors, like we can say these sensors are a kind of the strain gauge kind of sensors. So that sensors will actually sense the deflection in this diaphragm. Then sensors mounting location within intake manifold. Inside the intake manifold, we have to mount this sensor. Here you can see the sensor, such type of sensor which was fabricated by the General Motors. So here you can see the name of the General Motor, or the I can say the marking of the General Motor, branding of the General Motor on the sensor. So we have to put the sensor inside the intake manifold. Now another thing is the mass airflow measurement sensor. A mass airflow sensor or MAF is a sensor used to determine the mass flow rate of the air entering a fuel injection internal combustion engine. So in case of the fuel injection internal combustion engine, which is basically the diesel engine, we have to measure the mass of the air. So according to this mass, we can change the mass or the volume of the fuel supplied inside the cylinder. So for measure this mass of the air, we can use the mass airflow sensor. So here you can observe the mass airflow sensor, and the measured variable in this case, measured value will be mass airflow, mass of the airflow, direct, indirect measurement, direct and indirect measurement of fuel injector basic pulse width, then sensor technology reference. Sensor technology reference is the various forms including the flap type sensor, hot wire sensor, Kalman vortex and thick film diaphragm sensors we can use. Sensor mounting location within air intake manifold. Within air intake. So here you can observe a hot wire mass air flow measurement system. So this is the hot wire, and according to the mass flow of the air, this hot wire will lose its some heat. जितना ज़्यादा मास फ्लो होगा उतना ज़्यादा इस हॉट वायर से हीट लॉस होगा और ये उतना ज़्यादा ठंडा होगा, और ये जितना ठंडा होगा उसका रेजिस्टेंस इस वायर का उतना ज़्यादा चेंज होगा. So by comparing or by correlating the changes in this resistance of the wire with the mass flow rate, we can measure the mass flow rate inside the engine. हम क्या करेंगे, हमें ये पता है कि जितना ज़्यादा यहाँ से एयर फ्लो होगी उतना ज़्यादा तेज़ी से ये वायर ठंडा होगा, कूल डाउन होगा. जितना ज़्यादा कूल डाउन होगा उतना इसमें रेजिस्टेंस का वेरिएशन होगा. अब जब जितना रेजिस्टेंस का वेरिएशन होगा उस रेजिस्टेंस के वेरिएशन को और जो भी मास फ्लो हम यहाँ से कर रहे हैं उनको हम एक कोरिलेशन हमें मिल जाएगा। और फिर उसको रिलेशन का यूज़ करके जितना भी हमारा यहाँ पर रेजिस्टेंस चेंज होगा उस रेजिस्टेंस चेंज के अकॉर्डिंग हम बता सकेंगे कि कितना मास फ्लो यहाँ से हो रहा है, कितना एयर का मास यहाँ से फ्लो हो रहा है। तो इस तरह से हम एयर के मास फ्लो को मेजर कर पाएंगे। ओके, then the next thing is the temperature measurement. So different in engine we require to measure the temperature at various places, various different places. Like we have to measure the temperature of the intake air. We require to measure the temperature of the engine also in order to prevent this engine from the seizing, or we have to measure the temperature of the coolant also inside the radiator so that we can ensure the proper cooling of the engine. So for the temperature measurement, the direct or indirect measurement, we can measure this temperature at the various location. We can do the direct temperature measurement at the various location, and sensor technology reference thermistor or thermocouple we can use depending on the temperature range in order to measure the temperature. So thermistor and thermocouple we can use, and the sensor mounting location at different places where we require to measure the temperature. We can put the sensor at that particular place. So here you can observe this transit, the thermocouple and thermistor. These are the thermocouple and thermistor which we can use to measure the temperature. So in thermistor, the variation of the temperature change the resistance of their material. So in thermistor, according to the temperature, the resistance will change. So with respect to the resistance, we can measure or we can sense the temperature, corresponding temperature. While in the thermocouple, the changes in the temperature includes the voltage, while in case of this thermocouple, the change in the temperature induces the voltage between wires of different metals. So as you know and you might hear several times that the thermocouples use different wires, and it is related to the Seebeck effect. So different wires of two different materials we can use to form a thermocouple, and then changes in the temperature at this junction point or this joint, this will induce some voltage. Or so by measuring this voltage we can correlate this voltage with this temperature, and in this way we can measure the temperature of any body. The temperature measurement is basically depends on the zeroth law of thermodynamics. Okay, then from the beginning I am telling you that different actuators, like the actuators associated with the knock control, the actuators associated with the spark ignition, fuel injection, and the different other things. These actuators are basically work. These actuators are basically works with the corresponding to the location or the speed of the crankshaft. So we have to measure the location, or the I can say the position in more precise way. So we have to measure the position and the speed of the crankshaft. So for this measurement of the speed or the positioning of the crankshaft, we can use such sensors. So the measured variable in this case will be the engine speed and crankshaft different position. Direct and indirect measurement in this case, so we have to perform the direct measurement. Sensor technology, magnetic reluctance or Hall effect sensor we can use. Then sensor mounting location, on flywheel on end of engine crankshaft. So like you can observe a crankshaft, and here it is the an optical encoder or any other type of encoder or sensor we can use, or we can also use the Hall effect sensor also. So this 4 number is the reference marker. Reference marker will count the number of rotations, or I can say the speed of this shaft, crankshaft, flywheel, whatever, or this disc I can say. Then here you can observe this is the rotatory disc, this is the shaft, engine shaft, angle separators, angle separators, or the reference marker, stationary detector, this will detect the position, and then additional circuit, here it is the circuit, and then pulse signal. So basically when this reference point will pass from this sensor, then it will generate the pulse, and with respect to the different other markers it will generate some other kind of pulses. So by visualizing or by observing this pulse form, or the I can say the waveform, we can measure the speed or the positioning of the crankshaft. Another way of such type of measurement is the Hall effect sensor. So here you are very much familiar with such kind of the sensor. So if it is the Hall effect sensor, and here you some trigger wheel you can observe in this trigger wheel is having some gears. So when this gap will reduce, then there will be some due to this Hall effect or the Hall magnetic reluctance, it will generate some wave, and by observing this wave, when this gap will increase, then you will observe some changes in the waveform. So by observing this waveform, we can observe the position and the speed of the crankshaft. Another thing is the battery voltage. It is the simple voltmeter you can use for the measurement of battery voltage. Then throttle position. So to measure the throttle position, we can use the direct measurement of the throttle position, or the potentiometer is used for this purpose, and the location of the sensor is the accelerator pedal. So we have to mount this throttle positioning sensor at the accelerator pedal. A throttle position sensor is a sensor used to monitor the air intake of an engine. The sensor is usually located on the butterfly spindle or the butterfly shaft in case of any other kind of engine, so that it can directly monitor the position of the throttle. So when you require to measure the position of your throttle, then you can use the potentiometer. Inside here in this image, you can observe inside the throttle position sensor. Here you can observe the throttle position sensor, which is nothing but a potentiometer kind of sensor. Then oxygen concentration in exhaust gas. If you require to measure the oxygen concentration, then you can use this sensor to measure the oxygen concentration. So here you require to mount this sensor. So this sensor we require to mount at the exhaust manifold. Here it is the exhaust pipe. You can observe your cylinder, piston, exhaust pipe, exhaust valve. So this here somewhere here you can mount this sensor. This sensor will measure the oxygen concentration in the exhaust gases, and according to that it will set, or it will change the different related variables like the fuel supply or the gas supply inside the cylinder. So the measured variable in this case will be the oxygen concentration in the exhaust gas. Indirect measurement. Direct measurement of this oxygen concentration in the exhaust gas we have to measure. Then sensor technology, zirconia, titanium based exhaust gas oxygen sensor we can use. Sensor mounting, exhaust manifold, as you know already. Then electronic fuel injection. Electronic fuel injection system is used to inject the fuel inside the cylinder. This allows precise and fast control of fuel injected inside the cylinder. By control of the on time period of the solenoid operated injectors. So these injectors are basically the solenoid operated. So we have to control the operation or the timing of the solenoid operated valve. Delivery pipe delivery pipe fuel pressure is maintained constant by a fuel pressure regulator. As I have already told you that we have to maintain the pressure inside the supply manifold. Okay, and why we require to maintain such pressure? In order to ensure the directional flow from the nozzle to the cylinder. अब अगर सिलेंडर से कम प्रेशर नोजल में होगा तो सिलेंडर के अंदर जो भी गैसेस हैं वो नोजल के थ्रू बाहर आने लगेगी, है ना, क्योंकि ज़्यादा प्रेशर से कम प्रेशर की ओर ही फ्लूइड फ्लो होगा, तो ज़्यादा प्रेशर हमें नोजल में मेंटेन करना पड़ेगा। क्यों ज़्यादा प्रेशर मेंटेन करना पड़ेगा? बिकॉज वी रिक्वायर टू सप्लाई द फ्यूल जस्ट आफ्टर कंप्लीशन ऑफ द कंप्रेशन इंजन कंप्रेशन स्ट्रोक। तो जब इंजन के अंदर गैसेस कंप्रेस हैं तो दैट मीन्स कि उसके अंदर प्रेशर, एयर का जो प्रेशर है वो ज़्यादा है, और उस प्रेशर से ज़्यादा प्रेशर पर आपको सिलेंडर के अंदर फ्यूल सप्लाई करना होगा। ओके, सो फ्यूल के प्रेशर को हमें इंक्रीज करना होगा। So to increase the fuel pressure, we can use the pressure regulator, we can use the pump or the different other assemblies or the control systems. Then opening and closing times between 0.5 and 1 millisecond. Opening and closing time of this fuel injector is between 0.5 and 0.1 millisecond. Okay, तो इतने कम समय के लिए आपको फ्यूल इंजेक्टर को ओपन करना है। So accordingly, we have to design the entire control system for the electronic fuel injection. Then engine operating speed of 600 rpm. Injector on time can be controlled between 1 and 10 ms. Then come to the next thing. So here you can observe the injection electronic fuel injection. Here it is the injector, fuel injector for the different cylinder, delivery pipe, intake manifold as we have discussed earlier, fuel filter, we have to supply the fuel. So for this we can mount the different solenoid valve operator injector in order to ensure the proper injection, fuel injection at the particular time. Power driver application. So here you can observe the fuel injector IC package, electronic control unit. So this will control the air temperature. This will sense the air temperature, give the input value to this ECU. According to that, it will fix the different parameters like injection driver, fuel injectors, how much fuel you have to inject inside the cylinder, or in case of the diesel, in case of petrol engine, it will control the spark plug, knock sensors to control the knocking, then crank positioning, cam positioning, coolant temperature. These are some input variables, and accordingly we have to set the output variables like the spark plug timing, spark ignition timing, or the fuel ignition timing, or the amount of fuel which we have to supply inside the cylinder. Electronic clutch control to relieve pressing of clutch during gear change. Throttle cable of accelerator pedal replaced by closed loop control system. Accelerator pedal position sensor and servo motor connected to a electronic control unit for the gear change process. So electronic clutch control is also a very new thing in order to develop the automated car. So we have to design the electronic clutch control so that according to the speed, when the car will change the gear automatically, then this clutch will work according to the engine requirement. So the block diagram of automatic clutch control and the throttle system is the control of the clutch engagement and the disengagement, improved safety. This will improve the safety, and this system will control the clutch engagement and disengagement. Now block diagram for the automatic clutch or the throttle system. So this automatic control unit, this entire system will connected with the electronic control unit. This will supply the throttle servo system. This will supply the some control variables or control parameters to throttle servo system. But it required some input parameter according to which this electronic control system will set the output parameters. What will be the input parameters? Input parameters will be the accelerator pedal position, okay, then gear lever load switch, gear position sensor, gearbox input shaft speed sensor, then engine speed sensor. Then other things are the hydraulic power unit and solenoid controlled value, and then clutch release lever position sensor. So these are different values which we require to supply to the electronic control unit in order to actuate the automatic clutch throttle system. Okay, this automatic clutch throttle system will supply the relative parameter to the throttle servo system, and it will also supply the solenoid control signal and the clutch release to the hydraulic power and unit solenoid control valve. Okay, these are the, so it is the working of or block diagram of automated clutch and throttle system. Further, we have to study a few more things, and that are nothing but the chassis control systems of the automobile. So, chassis control systems include anti-lock braking system (ABS), which we have already discussed. In a brief, electronic damping control system, power assisted steering system, traction control system. So that are few more things which we have to discuss in our lecture. So, first thing is the anti-lock braking system or ABS, we can say. So, as I have already told you, that ABS will have some sensors which will sense the torque and the RPM of the wheel, and according to that RPM and the torque, it will apply the brake in the form of pulse. It will not suddenly jam the wheel or the movement of the wheel, but it will apply the brake pressure in the form of different pulses, so that the wheel will continue the rolling motion in the form of pulses, but instead of its instantaneous locking. So this process will help to control the vehicle, or this process will also control, we can say, to maneuver the vehicle over the path. So here you can observe the braking pressure. So initially it will apply the braking pressure without ABS. If your vehicle will not have the ABS, then at the moment when you will apply the braking pressure, so at that time the wheel speed will decrease, or we can say it will decelerate. So in this case, braking pressure is maintained and does not increase to the maximum value. So we can, so in this case, the braking pressure will not increase up to its maximum value. And in here you can observe the second case where the braking pressure is reduced after reaching at the particular amount of deceleration, or I can say after reaching at the particular speed, this braking pressure will reduce, so that the wheel will continue, so that wheel will continuously rotating or will be in the revolving motion. And here after that, so initially we have to apply the brake pressure. So it is the brake pressure is continuously increasing, and here the braking pressure is remain constant or maintained for a few time, and then after that this pressure will reduce and maintain a constant pressure, and then again it will apply a pressure, again it will increase this amount of pressure. Here you can observe it is increasing the amount of the pressure, so that we can decelerate or we can stop the vehicle without without its slippery motion or without its slippage on the ground, so that we can easily control the vehicle which having the anti-lock braking system. Another thing is the traction control. In the case of traction control, if there is slippery surface, then there is a possibility that your the wheel of this vehicle will slip with the higher RPM, which will not be proportional to the speed of the vehicle. So, to ensure the non-slippery motion of the vehicle or of the wheel, we have to adopt the traction control system in our vehicle. This traction control system sense the actual velocity of the vehicle, real-time velocity, which is not directly corresponding to the RPM of your wheel, but it is corresponding to this linear velocity on the ground, or the surface at surface. So by measuring that velocity, it will correlate that velocity with the wheel RPM, and if the wheel is revolving at the higher RPM, then it will apply some brake on that particular wheel to so that the RPM or the peripheral velocity of that wheel will get reduced. This is used to avoid the slippery motion of the wheel on the ground, like if you are driving your car on a slippery surface, like the road having some ice or water or heavy snow cover and other things. Now come to the next thing, which is the electronic damping control system. So in this electronic damping control, the actuators are dampers fitted with two on-off fluid control solenoids used to select one of four different damper setting, like normal, soft, super soft, and firm. So these settings are basically associated with the fluid pressure inside the damper, or we can say the another parameter which is associated with these different settings is the viscosity of the fluid which is filled inside the dampers of your vehicle. So we have to either we have to change the pressure, or we have to change the viscosity of the fluid. So by using some special kind of fluid, the damping we can control by changing the voltage or by supplying some current inside the damper. So for that purpose, we can use the microcomputer based an ECU. This microcomputer will sense the riding mode, either it is sport mode or the city mode, and according to the mode, or the according to the data receiving from the different sensors, like speed sensors, engine RPM, brake system pressure, steering angle, chassis acceleration, wheel acceleration, throttle position, load, according to that data, that can easily change the voltage, or that can easily change the setting of the damper, so that it will control, so in this way, so that it will control the comfort level of the suspension system. So this system is also displayed the present setting on the driver display, and give the command accordingly to the different dampers fitted with the suspension system of your vehicle. Then electronically controlled power assisted steering. This is the power steering, which is very popular nowadays in different vehicles, or especially this power steering was developed for the heavy vehicles. But nowadays this power steering is also takes place inside the car. For it is very comfortable nowadays to turn the car, to maneuver the car over the path. So this power steering is basically having some fluid control steering actuators that can turn the wheel, that can actually give the direction to the front wheel in order to change the path, in order to change the direction of the vehicle momentum. This entire system is basically associated with the sensors or different actuators. Sensors are mounted, sensors are directly connected with the steering wheel. According to that sensors actuate the power cylinder, that different valves associated with the power cylinders, so that the pressure will change inside this power cylinder. This power cylinder will supply the fluid pressure to the different cylinders, so that that can be actuated or give the direction to the front wheels or the any associated wheel. So that is all about the all about the electronics associated with the automobiles, or we can say the automobile electronics. Thank you.